question 2 is really a binomial distribution. It's like tossing a coin where you can have heads and tails. Here, it's about improvement or no improvement, right? It's also two results and for a given probability. So it follows a binomial distribution. However, when you have like nearly 30 observations, according to the central limit theorem, you can approximate that binomial distribution to a normal distribution, which enable you to use a z-score. Um, so pretty much like tossing a coin example, what you need to do is first, um, what is your observation? How many improvements you find, right? That is the number. I would say it's x, right? Um, and then you're gonna find what's the expected number. What's your expectation? Under null hypothesis, the null hypothesis should be 60% of the skein has improved, right? So basically you use the total number of observation, multiply that by 60%, that is your expected number of improvement. And we use the notation x bar. So basically use x minus x bar in the numerator. That is the difference from your actual observation and the expected number. That is the numerator for z-score test. And in the denominator, uh, you use a standard deviation, right? And for binomial distribution, the formula for standard deviation is the square root of NPQ, where N is the number of the total observation and P is the probability of improvement, right? And you're going to calculate that using your observation, like how many improvement you find divided by the total number, that is P. And Q is just 1 minus P, or we can also say the probability of no improvement. And so you got NPQ, square root of NPQ is your standard deviation, and it's just like tossing coin example. You get your z-score. I thought I said t-score several minutes ago. Like it's wrong, right? Here is a z-score test because we approximate this binomial distribution by a normal distribution. And in every normal distribution, you have to calculate your z-score to find its relative position in that Bayes curve, which gives you the p-value. So here again, z-score equals x minus x bar divided by standard deviation, where standard deviation is the square root of NPQ. And then you compare your z-score, you have your z-score, then you compare that in the z-score table, you can get like a number that is the probability, and you compare that with alpha, which I guess is 5% in this case. And you will draw a conclusion whether to reject the null hypothesis or not. So basically the intuition is first I assume my null hypothesis was right. There's actually 30%, 60% of skein improvement. Then based on my observation, I will find what is the probability that my null hypothesis being right. If that is less than 5%, then I will conclude, okay, my null hypothesis is not correct in the first time. I reject the null hypothesis.